Okay, so there's 4 of you here. I say we get started. In all honesty, I don't think this review should take long because it's mostly all right, click on me, share my screen. Also, this not recording. This review will be recorded. It will be available on the Learning Commons website in a few days. I will, and in the meeting, I'll show you guys where it is. But all right, iPhone 13 has left us. Okay. All right. Share my screen. All right. Hopefully, everyone can see my screen. If you have questions, feel free. The hell? There's an error here. Oh. Feel free to put them in the chat. Kathy will be monitoring the chat. So let's do this. New file. Rename Steinberg 111 P. All right. So as I mentioned before, your exam will oops, sorry. Your exam is going to be writing 2 like full-length programs. Oh, yep, thank you, Kathy. So first things off, you know how like you need a top for any like C++ program using namespace standard int main return 0, right? So this part's going to be given, right? So you're not going to be expected to memorize this portion. It's going to be given on your exams. Most of it's going to be like writing in the main. So let's see the topics you're going to have. Let's go through one by one. So the topics that are going to be on your exam, they're going to be, so you're going to have to do var. I have no idea. I think this is the first time Steinberg's teaching 111. His acronyms are weird. So you're going to need to know how to use variables, right? So variables, right? Let's do that real quick. I'm assuming everyone here knows how to declare variables, right? So if I want to declare an int x, right, you do declare like this. If you want to set it equal to a specific value, let's say 10, like this. And let's go over the variable types. We got int, double, right? This is basically a decimal value. Int is just whole numbers. You got a char, which is a character. So character meaning, let's say, just one letter, right? Or one character, right? And string. Main difference I want to point out between characters and strings is characters, when you declare a character, you have to use a single quotes right here. And strings use double quotes. So like, let me do an example down here. String lowercase. String name. Give me an error. Okay. Uppercase string. Oh, it's Java. Sorry. Yeah. So string name. Boom. There you go. All right, and then you got bool. Let me put these down here. Okay, so you got int x is equal to say 10, right? You got double I 3.14. We'll say char ch is equal to a. String name is name, and bool y is equal to true. Okay, this is how you declare variables. Any questions? Any questions at all? Anyone here? Okay. If there's no questions, I just want to briefly go over like the names for naming variables. So naming variables, right? So you can't have spaces, no spaces, right? So you can't say like int x, y is equal to 5, or let me not use x, y. Let me use w, z is equal to y, right? You can't have a space. It's gonna give an error. Spaces, but can include underscores, right? So WZ, this can be a variable name, and try not to use like, sorry, try not to use keywords. Yeah, that's a word. All right, so I'm not going to use int null is equal to 7, right? Or actually, I'm not using null. No, that's not good. Because like these types of keywords, they're also used in other references for C++ as well as programs in general. So like you can't do int is that like you got to create your own variable name, right? Other than that, that's about it for naming variables. And also, last thing for variables, if you declare multiple variables of the same type, declaring multiple variables of the same type, right? Say I want to declare int var1 is equal to 1, int var2 is equal to 2, right? I can declare them both in one line, right? So this becomes int var1 is equal to 1, var2 is equal to 2. There you go. And you could do the same thing without the equals. So you could declare them var1, var2, like this. Okay. Any questions? Any questions? Any questions? Mel's here. Is there any questions about declaring variables? If not, we're gonna go to, let me label this. var, this is the var section. Gonna have comp. No, this is math, zoom in. Yeah. So, in programming in C++, you could use various operators. So the operators you could use, at least for 111, is plus, minus, divide, multiply, and modulus. All right. Can it run? How do I run here? But anyways, so what we're going to do is we are going to show you examples of each, right? So I think this is just for numbers, right, Kathy? You're not going to test it on string concatenation.
Yeah, some of the operators are perform multiple functions, but I don't think he's going to test on that.
Okay.
Yeah.
So I think this is just for numbers. So before we go into this, let's go into a important rule. So whenever you do an operation between two ints will always return an int. Okay, what do I mean by that? Say I want to declare int num is equal to 3 plus 4. This is going to set num is equal to 7, which is an int, right? Or now if I say int different num is equal to 3.0 plus 4, this is gonna say 3.0 becomes a 3, 4. This will also set different is equal to 7. Now if I say double, right, this is gonna become 7.0. Right? So an operation between two ints, right? So if I add two integers, subtract two integers, divide, multiply, not really mod. I don't think you would do mod for doubles. But these four for integers, between two integers, will always return an integer. But if I do it with a double, right? So if I do, this is going to be useful when you do averages, right? So say I want to take the average of 5 numbers, right? So say I have, did you guys go over arrays? I don't think you went over arrays, right?
Not not yet. They
Not yet. Who said something in the chat? Not yet. Okay. So I'm not gonna confuse you with arrays. But say I want to add okay. Say I want to store C out. Well, I should go over C out and C in. We're gonna take a little detour here. Detour. So in C++, yoink. In C++, you have to do output and you have to take in input, right? So for output, you do C out. So it's gonna be hello world. N right? So this little n line, if you, oops, it's supposed to be a comment. Okay. N line, basically, next line. So this is going to print this onto the screen, right? Who has their mic unmuted? Mute. Okay. This is going to print hello world to the screen. So if I run it here, I don't think I can run it here. Hold on, chat. Hold on. Start debugging. Do I have it? Oh my God, damn it. Okay. Change course. We're gonna use a compiler. Online compiler, control A. Actually, GC++ compiler. Online. Right here. Should be better. Using namespace standard. C out. Hello world. It's gonna run. I'm gonna print it. Right? If I do end line, wait, I'm gonna show you real quick. Okay, so now if I use end line, I want you to notice that there's gonna be extra space here. See how there's an extra space now between the end? That means whenever you run the code, basically it prints whatever it prints, and then the cursor like waits at the end of the line. If you just end line, the cursor just goes to the new line. Okay, so this is output. Ooh, there's something in the chat. Oh God. It says the form cannot be found. Well, that's not good.
no, I've used I cut off the H at the end, sorry.
God damn it, Kathy. God damn it, Kathy. I'm sorry. We all love Kathy. So now, if I want to take an input, you gotta use cn, right? So say cn, and whenever you want to do input, always have like a prompt to like ask a user for input. So like say cout, enter an integer, right? Whenever you take an input, there's 3 parts we need, right? That's 3 parts. One, oops. The first part is we need to like declare something to store input. Right, so let's say we have int n. Okay. Part 2 is we prompt the user for the input. Right. So here we're prompting it. Oops. Easy. All right, there we go. And the last part is take in the input and store it in container. Everyone can see my screen, right? I'm not sharing nothing. Can someone confirm it? My screen sharing the correct thing?
Yes, it's showing up.
Okie dokie. So now we see in. We see in it. Okay. So let's run it here. Let's take away this. Let's comment out this portion. All right. So enter an integer. See how like at the end the cursor is there? So that's what I meant by like the end line stuff. Say I put in 10. Boom. And also print out. So now we see out n, right? Run it again. Integer. Now I want 15. Print 15. Right? See how it's stored? There we go. Okay. And when it comes to see out, I want you guys to notice, see how here, whenever you print strings, you got to put them in like the quotation marks, right? If we want to print out like stored variables or like numbers, we don't need the quotation marks here, right? So if I were to do see out n, right? And let's comment out this line again. It would actually print, say 15 again, it would print n, not what's stored in n, right? So I want to make that apparent, right? Let's run it again. 15, 15, right? I want to say I want to print out a number. I would do, let's say 16, run 14, 16. Okay. And one last thing, if you want to attach multiple things together using cout, you just got to use these two. I never know, are these like little arrows? Yeah, let's say they're arrows. And triangular brackets. But yeah, basically you could attach multiple things. I could do hello world once more. And then run it. 55. And it's gonna print out what the hell? Print everything. Okay, any questions? That was our little detour. I think I might just do the rest of the code here. Just to do it. And does anyone have any questions? Question. Any questions? Any questions? I will take the silence as no one has any questions. So let's move on to the next part. Back to math. Oh yeah. So let's do the math. So we got plus. So it's gonna say, let's say C out 4 plus 5 and 9, right? You could also do that for doubles, but once again, if you mix the signs, I want you to like, as to see this. Here, there's two ints. Here's a double and an int, right? So if I run it, they're both 9. I think if it's 9.9.0, it doesn't show the 0.0. Yeah, give me a sec. That was a bad example. But basically, this second 9 is treated as a double. And I chose a bad example to do it with. But if you were to like put these in code, this is an int. This first 9 is an int. This second 9 is a double. Maybe if it helps, let me show it like this. So now we do, let's do this. Int A is 4 plus 5. Did I have var? I think I have a var keyword. Int A is 4 plus 5. Oh, wait, no, I should do it like this. Yeah, okay. 4 plus 5 divided by 2. Divided by 2. By 2. There you go. See, that's the difference. See how this one's being treated like a double? This one's an integer, right? So 4 plus 5 is 9. 9 divided by 2 is 4.5, right? It should be. But because this is only integers, the output will be an integer, right? So 4 plus 5 is 9. 9 divided by 2 is 4.5. It drops to 0.5 and it will output 4, right? Whereas in this example, the output will be a double. Because 4.0 plus 5 is 9, but not just any 9, it's like 9.0. And 9 divided by 2 is 4.5, which gives 4.5. Okay? We'll talk about this more when it comes to division, but hopefully I just want to like make the point that if you mix the types, so double plus an int, or a double with any operation with an int, or it's double with double, will always result in a double. The only way it's going to be an integer is if it's both integers, if everything is an integer. Right? So if I did this like divided by 2.0 as an example, it would also return 4.5 because this is a double. Once you introduce a double into the formula, the result will always be a double. Okay? So that's that little spiel. Once again, I don't really know. We're gonna do a bit of the practice questions in a bit. After we want to get to like bool iterate and the iterations. So yeah, so let's go over subtract. Oops, subtract. Once again, any questions, feel free to put them in the chat, or if you want, you can unmute your mic and speak them. It gives me a break from speaking for 2 straight hours, but anywho, 4 minus 5, right? Right. And once let's do a one with doubles, 3.5 minus 3.14 and 9. Bingo. So you will get negative numbers and 0.36, right? Multiplication, once again, most of it's like similar, 4 times 5, n line, C out, 4.0 times 5.5. 9, run, 20, 22. Don't get confused, this 22 is treated as a double. It's just if it ends with 0.0, 22.0, it's the same thing as 22. Okay? And division, it's more. I want you to be careful because once again, if you have, say you have 5 divided by 4, right? This is going to be 5 over 4 is 1 1/4. It's going to drop to quarter, right? So it's going to only show the 1. But if I do C out 5.0 divided by 4, it will print 1.25. Okay? And last but not least, we have modulus, which is basically the remainder. So it's basically saying 5 divide mod 4, right? 5 divided by 4, you get 1 1/4 because that 1 is a remainder. So this will print 1. Yes. Right, if you want a more distinct example, see out 99 mod 10. 10. They should give us 99 divided by 10. You get 9, remainder 9. You get, okay. And mod, I would avoid using with doubles. I mean, you could try and like just to see if you're curious, but it's mostly for ints only. Okay. Anyone have any questions? Any questions at all? Everyone good? Okay. If no one had any questions, let's talk about comparisons. Oh, comp. Okay. So let me copy and paste this. All right. So comparisons are ways you can, if it doesn't make sense already, compare two things. And the main comparisons that are used are usually like greater than, less than or equal to, greater than, greater than or equal to. These are mostly for ints. And you could also use not equal to, right? Or equal to. Be careful. If you want to check if two things are equal, you have to use two equal signs because remember, one equal sign is how you declare things. Okay, so let's do this. Let's say C out 5 is equal to 5. Right? This will print. What do you mean? Three equal signs?
You might have to put it in parentheses.
Oh, shoot. Yeah. Yep. So 1. Basically, 1 means true. 0 means false. All right, so if we do C out 3 is greater than or equal to 10, our response should be a 0. Okay. I mean, you could use all of these for ints. I think these two can also be used for strings. I'm not sure. I might get my Java and C++ mixed up, but let's try it. Did they learn comparing strings?
They haven't learned about strings yet. I think the comp should be about if statements and stuff like that.
Okay. So like comp, so these are like the Booleans, and they're mostly used in if statements, right? So let's have it here. If 3 is greater than 5, C out ABC, right? So this is checking if this is true, right? We do whatever's in this block, right? So any code that's within the if block is only performed if the comparator here is true, right? It shouldn't be because it's nothing there. Otherwise, this, there you go, right? So that's if statements. Not sure if you learned this, but also if you want to like stack multiple things together, right? So connecting different booleans, we use or. Oops, not typing or and ands, right? Not sure if you learned this. Basically, this is saying if the first statement is true or the second statement is true, then do whatever in here, right? So we can do this. If 3 is less than 5, or something like that. 3 is greater than 5, or 4 equals 4. See out this, and it should print it out. Because even though this one is false, this one is true, right? And it can be the case that both of them are true, but this is just at least as long as at least one of them. However, if I were to put and, we put this at least one true, all are true, right? So if I were to put and, it won't print anything because both of them needed to be true, and this one's not. Okay. And then when it comes to if statements, say you want something to run even if the statement is false, you could have else, right? So you could have else, C out EF, right? So even though this part won't run, this part will then run, right? However, if this runs, this won't. Let me show you guys what I'm talking about. DEF, do that. ABC, right? So if this doesn't run, this will, right? And you can also stack if statements. So we could do if 3 is less than 5, else if 4 is greater than 10, else if 4 is less than 10, else see out. Right. I'm tripping, sorry. Right. So it checks this. If this is true, it's not true. So it then checks if this is true. In this case, it was true. But if this wasn't true, it would have then went to else. Right. Any questions? I know this seems very boring. I just want to make sure everyone's good. So var, math, comp, bool. Let's do some examples. Let's do an example with bool. Kathy, pick a number between 1 and 4. Inclusive.
5,
God, what? Why?
3.
3, okay. Given 3 numbers entered by a user, determine whether any 2 add up to the third number. Let's do that one. That one's interesting. Let me paste this here. Control C. Also, if you want to do the nice thing about comments, if you want to do comments, you could leave single line comments, you just use 2 forward slashes. Multiple line comments, you got to use like the star as well, like this. Okay. So given 3 numbers entered by the user, determine whether any 2 add up to equal the third number. Right? So once again, let's do this real quick. So we're going to declare 2 numbers. And let's say A, B, C. Right? And let's ask the user. So let's first ask for first number, right? So this is an example of some type of program, a question that'll show up on the exam. You're going to be given this type of prompt, and you're going to be told to fill in the code. So we got int ABC, ask for the first number, C out, enter first number, right? C in A. Now we could ask for a second number. I'm going to copy and paste this. Ask for second number, CNB. I'm going to ask for third number, CNC. Okay. And then we want to check if any two numbers adds up to the third, right? So what are the possibilities? A plus B equals C. That's the first one. A plus C equals B. Or B plus C equals A. And that's it. A plus B equals C, A plus C equals B, B plus C equals A. Okay, so there's 3 cases, right? So what do we do first? Let's choose first case. So if A plus B equals C, right? And as a little bit of a note, the program will follow PEMDAS. So, but if you still want to like for any like math stuff, it follows PEMDAS. But if you want to like make sure it does, like you want to like be certain of it, you could always include an extra parentheses, right? So if A plus B equals C, we'll just say C out the first and second number add up to the third, right? Else if something like BA plus C equals B, you can see out the first and third number add up to the second Don't forget at the end of your lines, always include the semicolon. It's gonna give an error otherwise. So else if a b plus c equals a, you can see out the second and third number add up to the first. Okay. Otherwise, that means none of them add up. You could be like, see out none of your numbers add up to the third. No, two of your numbers add up to the third. Add little sad faces. Okay. Any questions about how we did this code? Just run it and see what happens. First number 5, 6, 11. The first and second number add up to the third. Run it again. 4, 2, 2. Second and third add up to the first. 11, 21, 10. First and third add up to the second. 1, 1, 1. No two of your numbers add up to the third. Okay. Any questions? Any questions at all? Any questions whatsoever? And you guys really are quite a bunch. Okay, then we're gonna move on to. I'm gonna keep this up to the screen for a question. What if we want to combine the if statements? What do you mean by combine the if statements? Oh, sure. Right. So remember how I talked about like ifs and ors? So this is one way you could do it. If you want to like check for each specific case. If you want to check, right, if like any of these first three happen, right, just use ors, right? So if this or this or this, we want to print, we could system out, see out two of your numbers add up to the third, else print this. Right, if you want to just look at it generally, we'll save. All right, so let's run it. 1, 2, 3. Two of your numbers add up to the third. One more time. 3, 2, 1. Bingo. 2, 2, 2. There you go. So if you want to like check each case, you do this. Or if you just want to check it generally, you could just add ors, right? So if this is true, or this is true, or this is true, then it's printed out. Otherwise, we don't. Okay. Any questions? Any questions? If there's no other questions, let's do another example from the next topic, which is I guess iteration. Hold on. Okay, iteration 1. Okay, let's do this number 4. Compute the average of all non-zero numbers entered by a user. Let's do that one. Is everyone okay if I delete this program right here?
Non-zero numbers up to what?
Non-zero. They basically input non-zero numbers up until zero. So once they enter zero, the thing's done. Wait, enter. But that's a great question. Let's say until zero, until the user enters zero.
Don't you
So
mean up to 100 or like 1,000?
compute the average of all non-zero numbers entered by a user.
Oh, entered by using my phone.
No worries. That was a good question. Should have read it. Is everyone okay if I delete this main code? Does anyone want to take a screenshot of it or something? Everyone good? All right. I'm going to let me actually copy and paste it so we have it later. Okay. So compute the average of all non-zero numbers entered by a user. Right. Just for simplicity, let's just say they keep entering numbers until they. So once they enter zero, we stop asking them. So let's do that. Let's have an int total, right? And then we're gonna say double not numbers, right? I'll show why this is double in a bit because also one last time for anyone who here who hasn't, please fill out the attendance form. It's the last time we're gonna ask that because this is someone in chat. Yep, we need especially because this is the first time we've done it for Steinberg. It really helps if you guys give feedback on how I can improve. So let's ask. So remember we got to do. So let's int n. This is going to be whatever the user inputs at the time, right? So what do we check? While n is not equal to 0, right? Let's say it's fine. While n is not equal to 0. Let's first ask. So C out, enter a number, and we see in n, right? And while n is not equal to 0, we basically want to keep asking. So what do we do? If n is greater than 0, i.e. if it's a positive number, right? Let me just put it here. And if user enters 0, if n is greater than 0, we're going to say total equals total plus n, right? So basically, whatever total is, we're going to add n to that total and set that equal to total, right? So as an example, if total is 10 and the user enters 5, we set the total now equal to 10 plus 5, which is 15. Okay. Another way of writing this is total plus equals n. Right. It's basically saying total is what this is basically this in a shorter form. Right. And put these in parentheses. But either one works. Right. If you want to be safe, might as well just go with this. Right. And then we want to increase the total number of numbers they entered, those numbers, plus 1. Once again, you could take numbers right like this, plus equals 1. Or even if you want to do it even shorter, just do numbers plus plus. Okay. Just keeping track of the numbers. Sorry, this goes into F. Because remember, we only care about the positive numbers. Negative numbers we don't care about. Okay. And then yeah. So this is we're adding the numbers up. Oh my word. And then afterwards we divide. What's the question again? Sorry. The average. Okay, so how do you compute the average? You add up all the numbers and divide by the total number of numbers, right? So we're going to say double average is equal to total divided by numbers. And because this is an integer with a double operation, the resulting number will also be a double, right? If I were to have done int numbers as well, and then say like int average, this would then give, say I entered the numbers as an example, 1, not 5 and 4, right? The two numbers I entered that are positive. And I want to find the average. The average of these two numbers, you add them together and divide by 2 because there's two numbers. So this would give us 4.5. But if we declared the numbers as int, this would be 5 plus 4 over 2, all integers. And we saw in the previous example a while ago that that would give us an integer as well. So our average would be 4, where it should have been 4.5. Okay. So then we're just going to print this to be sure. So let's see out the average of all your positive inputs is, once again, we want to hatch average, so average. Okay. So let's run this. What did I do? 15. Oh. Okay, let's run it now. Enter a number. 1. Oopsie daisy. I forgot to ask. Sorry. Afterwards, we have to ask again, right? My bad, chat. You got to keep asking. Right? Enter another number. Let's run it now. 1, 14, -3, 11, 2, 4, 6, 0. The average of all of your positive inputs is 6.333. 1, 15. I think I'm going to trust the math. Anyways, that's how you do it. Any questions? Anyone have any questions? Because we're repeatedly asking for input, we have to include this cout. Okay. Any questions at all, folks? I'll give you guys a second to take a picture if you'd like.
Someone asked if you can do another while loop example.
Can we do another while loop example? Sure. Why not? All right. Let's do the example of force the user to enter a number divisible by 5. Okay, sure. Can I delete this? I'm not gonna delete it. Let's save it here. Okay. Force the user to enter a number divisible by 5. Okay. Once again, what do we need? We need to declare a number, integer container. So let's say int not n. Sure. No. I'm going to cout. Enter a number divisible by 5. Right? I'm going to cin n. So now we want to keep asking the user to enter the number as long as we keep asking the user for a number until it's divisible by 5. Okay? So when do we ask? If
You used you cin to num. You declared num, and then you
sorry. Thank you, Kathy. So while num mod 5 is not equal to 0, what does this mean? So mod gives us a remainder. If the number we entered the remainder when we divide it by 5, if it's not 0, we want to keep asking. So, right, let's do C out. I said divisible by 5. Little 5. Enter another one. All right, and we see in no. All right. So this is basically saying, while the number they entered, if it's a remainder when you divide it by 5, if it's not 0, that means it's not divisible by 5. If a number is divisible by 5, then that number, mod 5, should be 0. Right? As a little side note, another way you could write this is by taking this. As you do not non-mod 5 equals 0. Right? This is basically saying, if it's not this, then this. They're the same thing. So if you find it a bit easier to understand, you can write this. This is also the same thing. Okay. So let's run it and see what happens. 3. Enter another one. 6. 11. 14. 15. Here you go, it ends. And so you do a little equal this. Right? Sorry. I'm an idiot. Run. 4. 3. 2. 1. 11. 10. Thank you. Right? That's another example of a while loop. Is everyone okay with this? Any questions whatsoever?
I think you need to put the sorry if my roommate's TV's blaring in the background. I think after the while, I think you
Mhm.
need to put if else num mod 5 equal to 0. You need to see out the number is divisible by 5.
Well, the idea is if it's so once we like exit this while loop, that means the number they entered is already divisible by 5. Because if it wasn't, then we want to. So are you saying like something like, let me see, if num mod 5.
After the while loop, if the number is divisible by 5, meaning num mod 5 equal 0. That what you're doing, yeah. That's what I'm
Yeah.
saying. I'm just yeah.
So like something like your number is divisible by 5, something like this.
Yes.
But here's the thing. If we're outside the while loop, then the idea is the number is already divisible by 5. Because if it wasn't, then we would have still been in the while loop, right? Because this while loop keeps asking for a number as long as it's divisible by 5. And this would work, right? This would definitely work. Like if we do an example here, 5. Boom, your number is divisible by 5.
Yeah, but isn't that what they will ask us on the test?
No, I mean,
The second part. Or
the
the
second
second
part,
part will not show up on the test.
if
Because
for
I
this
get the
question,
gist of I pretty much get the class. I've been passing the quizzes.
Mhm.
I've been doing well. I'm extra help because you know I'm sort of a computer whiz, but the programming language I want to master it so I get 4s. You know, I'm here for that.
Yeah. In this question specifically, you wouldn't need this part after the while loop. Because all the checking, like this portion right here, is already done with this. Does that make sense? So like if you just write CL,
Gotcha. I'm just you don't even have to put the if statement. You can just
no,
put okay, cool.
right here. Right. I get what you're saying, like if you want to check it again afterwards, but like the idea is it's already checked here. So it doesn't really, it's like it's repeated code in essence. Right. So we test it here. I put
That's why I always when Professor Steinberg was lecturing the while loop, I was absent. So that's why it took what reading the PowerPoint and and reviewing the code. I missed the quiz for it, but I eventually got it. I just didn't realize you didn't need another if statement. Thank you.
no problem. No problem. But yeah, the check's already done here, so another if statement is pretty redundant. But good question, good question. Any other questions? See, it's good when we have other people talk. It's I'm not talking to a screen of boxes with names on them. If everyone's good, who asked for another? To the person who asked for the while loop, another while loop example. Do you want another one? Are you good? Is everyone good? I think it was Michelle that asked. Everyone's okay?
Hello. Yes, I'm good. If you could just go a little over like the actual like condition itself. There was a question that um was like try to find like the summation of all the numbers, and it was like while num is greater than 0, and I guess it was just like a little confusing for me, that part, like the actual condition itself.
Okay, so was the
Could you send
question,
the problem in the chat?
I think
Yeah.
the question is if you like, do you ask the user for inputs and you add them all up as long as
Yeah,
they're
like
positive?
find um I'll write it in the chat.
No worries. I think I understand what you're saying.
It was like enter a number like 1, 2, 3, 4 kinda, and then find the sum of 1, 1 plus 2 plus 3 plus 4.
Hmm.
Um,
So it's like as long as the user keeps entering positive numbers.
yeah, I believe it's that.
Now let's do that. I have a little side quest here. Side quest. Okay, so once again, how do we prepare for input? Int num. We see out the user enter a positive number. And we see in num. Right? And so while num is greater than 0, I'm gonna go over this in a bit. We're gonna do, let's have a total. Let's also have a total. Total equals 0. We're gonna set equal to 0 initially. We're gonna do total equals total plus num. And at the end, we want to print the total. So we want to see out your total is total. Okay. So you have a question about this part right here, right?
Yeah.
Okay, so a little bit of a sidetrack. Remember how for if statements, if we have some statement here, and then we run.
Mm-hmm.
So this runs if this portion is true,
Yeah.
right? Similarly, so when you want, in this scenario, we want to stop asking for input once they enter a negative number, right?
Yeah.
So that's why we put kind of the opposite here, because we want to keep asking for inputs as long as the number they entered is positive. Does that make sense?
Yeah, I understand that part. Oh, I guess I did my code a little differently. After I did while num greater than 0,
Mm-hmm.
I did sum equals num mod 10, and then num divided divided by 10, and then num plus
Oh, wait. So you're saying they enter a number and you add up all the digits in the number.
yeah. Okay.
Oh, okay, that's a whole different question. Okay.
Okay.
Backtracking, int num, enter a positive number, cn num. Okay, let's assume they do enter a positive number. Okay, now I get what you're saying. Okay. So in this scenario, we want to add up the digits, right? So, oh, I can draw here, one sec. If I enter the number 1, 2, 3, 4, right? I want to add up each individual digit. So in order to do that, we could have a sum variable. Say sum. What the hell is that at? Sum. What we could do is we could always take the last digit of the number and add it to the sum, right? And then we just chop it off, right? So then we always keep adding the last digit, right? And we keep going as long as there's digits left to add, right? So how do we do that? The user enters a number. Let's have some total as well. The total of the, no, that's not that. The sum of the digits equals, right? So let's do the inside. Let's do the inside of this while loop first, and then we'll have the parentheses. So what do? We want to add the let me set it equal 0. Sure. We want to add the last digit of the number to the sum. How do I get the last digit of a number? I want to add it to the sum. So sum is equal to sum plus, and I want the
Int
last. Sorry,
It
what?
minus. It minus.
Not minus. Remember, I want this last digit. So as an example, I have the number 12. I want this last digit. I want the 2 only. How do I get the 2? What operation?
The module?
So module, but what would I mod by? Mod. I just want the 2, remember.
I
Just
think
12.
she said it before. One place, one
So that
decimal
would be,
place forward.
so what number
So
would
it'd
that
be
be?
10. That'd be 10.
Yep. Mod 10.
She said it before, yeah.
So num mod 10. Right? It takes the last digit. Always gives the last digit. So now we have the last digit and we added it to the sum, but we also have to increment it because remember, um, if we don't then like take off the last digit, like see here how we added the last digit, then we take it off. If we don't like do the taking off portion, it's gonna result in an infinite loop. We're just gonna keep like adding the same digit over and over and over again. It would, and the code would never stop, right? In order to prevent that, we then had to take off the last digit, right? So now given, and remember this goes back to like the integer division that I mentioned before. Given 12, I want to get 1, right? How do I go from 12 to 1? What do I do? What operation do I do to 12?
Mod 100.
Not mod 100. 12 mod 100 will give me a 12.
The num divided by 10?
Yep. If you divide by 10, it basically gives you this 1, right? And it chops off the 2, right? So you would do num equals num divided by 10. Okay? Any questions so far on these 2 lines? This part gives the last digit of a number. This part takes it away.
Okay.
All right? And last part, we need to know when we got to stop, right? So 1, 2, 3, 4. I add the 4, take it away. Add the 3, take it away. Add the 2, take it away. Then I add the 1. 1 divided by 10. Integer division will give us 0. Once I hit 0, do I have anything left to add to the sum?
No.
No. So basically we keep going as long as it's greater than 0. Right? So while num is greater than 0, we keep doing this process.
Okay.
And,
And
and because you put num greater than 0, it stops at the last digit because the digit has to be greater than 0.
Yep.
Okay.
Is that, Michelle, are you
yeah, I
any
see.
questions?
So it's not like, because I know we put sum equals to 0 as
Mhm.
well. It has nothing to do with num greater than 0 or
No, because there's no sum in the if statement.
okay, I
Just
see.
use the sum to add.
Okay. Thank you.
And let's clear this my drawings and let's run it. So if I want to, oops, sorry, did I forget yeah, that was a semicolon. So let's do 1, 2, 3, 4. Sum of the digits is 10 because 4 plus 3 plus 2 plus 1 is 10. Okay. Is everyone okay with this code? Any questions?
Oh, do we have to increment it? Do we have to put num plus plus on line 14? Or not really in this case since it worked out?
In this case, we don't want to do that because we don't want to change the num entered.
Oh, okay, okay.
What we're using in order to like do the loop is basically in essence like the length of the number. Right? So we have 1, 2, 3, 4. We keep going as long as we have numbers left to run, right?
Okay. Yeah.
That's why we do the num divided by 10, and then while we check here. I think the
Okay.
num plus plus, you'll see examples of that, especially in like for loops, when we want to go one by one by one.
Okay, okay. Thank you.
No worries. Speaking of for loops, let's do an example. So let's do a simple example. Let's do say hello 10 times, just to like show you guys. All right, so if everyone's good, I'm gonna delete this. The side quest is now gone. All right, so we're gonna say hello 10 times. Right, so for, and this is the main difference between a for and a while loop. So basically, let me, you guys, a while loop. If you were, oh, okay. Okay. So if I want to like say, there's two ways you could do this. If I want to like print hello world 10 times, I could say int counter is 0, right? And while counter is less than 10, I could do cout hello world and line. Now we do counter plus plus, which in essence is just counter equals counter plus 1, right? Let's run it. Print it 10 times. And this is perfectly fine, right? You declare a counter, you declare something like to keep track of, you keep track of it here, and you update it here. Okay. However, another way you could do this is if you have a for loop, right? So an alternate method that programmer has created is for loop. For int, now we could use counter. Usually we use I for index, right? So you'll see like I, J, maybe sometimes K used. Int I is equal to 0. I is less than count 10. I plus plus, cout hello world and life. Oh, sorry. Hello world and life, right? So if you guys see this, oops, this portion is here. This portion is here. And this portion is here. They're basically inherently the same thing, right? These two blocks of code. And if we run it, you had a space here too. It runs and line. Run. We see that they both print out hello world 10 times, right? So when you use a for loop, you use a for loop whenever you know how far you want to go, how many times you want to repeat something. Here, since we know we want to repeat it 10 times, we do it for I0, I is less than 10. While loops are usually more useful when you don't really know how long you're going to go for. Like as in the last example, we don't know how long the user input could be. Like if it's 1, 2, 3, 4, we just have to add 4 digits together. But if it's 1, 2, 3, 4, 5, 6, well now it's 6 digits we have to add together, right? So when the length of the loop is unknown, best bet is usually a while loop, right? But if we know we have to print hello world 10 times, right? It's most likely it's better to use a for loop. Any questions about that? Michelle, do you see like the use of the I plus plus here?
Yes, thank you.
Matches the plus. Okay. Do you guys want to do one more example using for loops? I think we have another example using for loops. And is everyone okay? Anyone have any questions? Trying to look at more examples. Let's do this one. Ask the user for a number, print the first 20 multiples of that number. Okay. Ask the user for a number. Numbers of the number. Okay. So once again, we want to ask the user. So we declare int n. We see out enter a number. Cn n. And now we can use a while loop. Yeah, that'll be fine. But since we know we want to print the first 20 multiples of that number, we can use a for loop since we know how long it's going to be. So we can do int I is 0. Let's start at 1 actually. I is less than or equal to 20. I plus plus. Right. This is a slight note here that I want to bring up. If you start at 0, right, you start at 0. And if you start at 0, you usually use strictly less than 20 or strictly less than however long it is because it includes 0. So if you were to do less than or equal to, this would actually print it 21 times. Let's start from 1 here because we want to first 20 multiples. So if you use 1, usually use less than or equal to. Okay. And I want to print the first 20 multiples. So then I see out, I could do the number they entered times the current index we're on, right? Times I and line. And this is basically saying, so if I is 1, this would print the first multiple, n times 1. I is 2 would print n times 2, which is the second multiple. 3 would print the third multiple, 4 would print the fourth, etc. up until 20. Right? And if we run it, enter a number, I want to print 2. Give me the first 20 multiples of 2. There you go. 2, 15. There you go. First 20 multiples of 15. And it's useful for using a for loop here since we know we only want the first 20. All right. Any questions? Any questions whatsoever? All right. If no one has any other questions, let's do one more example. And this is iterator 4. Let's do actually one more example for it 3, then we'll do it 4 to finish it off. Print all powers of 2 less than 1 million. Okay. So now I want to print all powers of 2 less than 1 million. Does C++ have a power function? I don't think they use functions. This might be a nested for loop.
And in the notes, it said times I or times n or something. I remember looking at it on Venus, the example he gave for the code.
For this question?
Yes, I think he would. I'm not on campus, so I couldn't access Venus, and I didn't set up the VPN. So, yeah, I think it was I to the power of n. I think.
Okay. So let's do that. Let's do a different one. I don't want to do this one's a bit complicated.
I think you can set up the for loop, and once it reaches 1,000,000, it'll leave the for loop and just keep multiplying by 2 onto the variable.
So that would be nested, no? So like for int I is equal to 0. I is
Yeah, she might have said it might have been I to the power of 2.
Uh, Start at 1 and then
Something like that.
change the counter by multiplying by 2 and have the middle condition be that it reaches 1,000,000 or whatever.
and then okay, so then I times equals 2. Oh, okay. Let's see out I and like oh, it's not bad. Run, see what happens. Oh, there you go. Neat. Okay, so you start from I is 1, I is less. Okay, I don't know why this didn't come to my mind. This is one of the examples where it's like you're adjusting the updating portion. So like right here, instead of doing I plus plus, you update the counter by doing times equals 2. Basically. Oh, so that's not bad. Okay. Does anyone have any questions about this? If you're confused, please say. The only idea is that this portion right here. Instead of doing this I plus plus lesson, etc., you would do I times equals 2. And it just keeps updating. So it's 1, then 2, 4, 8, 16, etc. Any questions? Any questions?
So the I times equals 2 is just you're just multiplying the like 2 times 2, right? After. So you just keep multiplying by 2 every time, right?
That's basically it.
Thank you.
Okay. So let's do one more example. Iterator 4, example 7. Force the user to enter 5 positive integers and print their sum. Okay, let's do this one. All right. So, all right. Let's do a while loop here. I'll show you why it is the case. So we declare an int n, cout, enter a positive integer. We cin n, and we're also going to have a counter. Counter equals 0, right? So we want to keep asking 5. So while counter is less than 0, not 0, less than 5, I'm sorry, right? And the very end, we want to do counter plus plus. While counter is less than 0, we want to do this. We want to add, no, we don't want to add this. We want to do, we also have I need a total. Total equals to 0. Total equals total plus n. Cout, enter another positive integer. Cn n. And we need to counter plus plus. Okay. However, that's if they enter a positive number. What if they enter a negative number or a 0? Right? And we're just assuming that 0 isn't positive, right? So this is if n is greater than 0. We want to do this. Otherwise, that means the number they entered is negative or 0. We want to prompt it again. Cout, enter a positive integer. Let's do this. We said positive right? And then we see in that, right? So basically this first portion is checking if what the user enters, if it's actually positive, right? Then we increment it. We do what we need to do, right? Because we're forcing the user to enter 5 positive numbers, right? Otherwise, if they don't enter a positive numbers, we only want the first 5 positive numbers. We say, oh, wrong input, enter a positive. Wait, let's do this. Wrong input, enter a positive integer, right? We ask them for something else, right? At least how I'm interpreting the question. And then we'll see out the total of your 5 positive integers equals total. Right, let's run it. I forgot another semicolon. Darn. Positive number. 1, 2, 3, 4. Now if I enter 0, wrong input. -1, wrong input. -15, wrong input. 5. Sorry, if it's 0, 1. So it's not. Oh. 0, 1, 2. I'm tripping this. 0. Oh,
You put greater than 5.
where? Here?
Yeah.
Most less than.
Oh, it's less than. Okay.
I think I gotta start from 1. Because technically when the first, let's try it now. 1, 2, 3, 4. Yep, there you go. 1, 2. That's not right. If, and this is supposed to give.
You might have to add total equals total plus n at the end after the while loop, because it leaves without including the last number, I think.
Right now. One plus 2, 3. It's not, where'd you get 24 from, buddy?
Because it's doing it twice now.
Oh. Uh. Okay. Okay. Now it works. Yeah, you're right, Kathy. It didn't do this for the last one. Because it's maybe if I do it start at 0. Yeah, it wouldn't make a difference. All right, anyways. But yeah, this one works. All right. Does anyone have any questions? Any questions at all? Other than that, I think we're pretty much done. Kathy, if you mind, could you post the feedback form in the chat?
Yes, in a second.
Sounds good. But yeah, if no one has any other questions,
Thank you. This was very helpful.
no problem. I really hope it does help everyone. This review. Hopefully more people showed up. I think your class might be pretty small though, but please fill out the feedback form though. I must know what I could do better. And then, yeah, I think that's pretty much it. Anyone have any last questions? Any questions whatsoever? Once again, thank you guys. Oh, let me show you guys where the thing will be. See, not learning commons. Okay.
Yeah, we'll also be sending out a message with a link to where the recordings are kept.
Mhm.
It should be under resources.
Yeah, so if you go into resources, computer science resources, right here. So for CS111, you got right here.
Thank you and take care.
Thank you. So you got your recording upcoming here for Steinberg. All right. And yeah, if no one has any other questions, good luck in your exam, and yeah, I think that's pretty much it. Thank you
Yeah.
all.
Good luck, everybody.
Thank you.
Bye-bye.